Today we will learn some of the solid examples on area under the curve from applications of definite integration. So the first example is using integration, find the area of the region bounded by the line 2y plus x is equal to 8, the x-axis, and the lines x is equal to 2 and x is equal to 4. So first of all, we must able to draw the graph of the given function. So 2y plus x is equal to 8. If you put x is equal to 0, you will get y is equal to 4. So 0, 4 is the first point through which this line passes. Then to find the other coordinate, put y is equal to 0, you will get x is equal to 8. So 8, 0 is the second point. So join these 2 points and draw the line. So this is the curve, given curve. Now the area is bounded by x-axis, okay, and the lines x is equal to 2 and x is equal to 4. So these are the two lines. This area we want to find out. So this is the area bounded by x-axis. So we will use the formula y dx. Integration is 2 to 4 y dx. What is y? Y from the curve. What is curve? 2y plus x is equal to 8. So what is y for that curve? Y is equal to 1 by 2, 8 minus x. So 1 by 2 is a constant, so we can take outside. Integration of 8 minus x is 8x minus x square upon 2. Now lower limit and upper limit. Put that values and say simplify. You get 5 square units. So this area is 5 square units. The next example, the curve is y is equal to x square, the lines is x is equal to 1 and x is equal to 2, and this area is bounded by the x-axis. So y is equal to x square is the or that is x square is equal to y is the parabola opening towards positive direction of y-axis. So and the limits are given that x is equal to 1 to x is equal to 3. X is equal to 1 to x is equal to 3. So this is the curve. Again, if this area is bounded by x-axis, so you have to use the formula x is equal to a to x is equal to b y dx. So 1 to 3 y dx. What is y for this curve? Y for this curve is x square. So put x square. So its integral is x cube upon 3. So 1 upon 3 is a constant, so we can take outside. Then put lower limit and upper limit in x cube. 3 cube is 27, 1 cube is 1. So 27 minus 1 is 26 upon 3. Square units is the area of the given shaded part. Now the second example is y square is equal to 4x. So it is a standard parabola which opens towards the positive direction of x-axis, and the limits, the lines are given x is equal to 1 and x is equal to 4, x is equal to 1 and x is equal to 4. Also it is given that y square is positive, y is positive. If it is not given y is positive, then we would have to find the area, this much area. So for then we have to include this also. If it is not given y is positive, but it is already given that y is positive, so we have to just think of the area lies in the first quadrant only. So again the area is bounded by x-axis, then the curve and the lines. So we have to use the formula integration from 1 to 4 y dx. So what is y for this curve? Y for this curve is, as y square is equal to 4x, y is root 4x. So that is 2 root x. 2 is a constant, we can take outside. Root x can be written as x raised to 1 upon 2. So its integral is x raised to 3 by 2 upon 3 by 2. So after simplifying, we'll get 2 by 3 x raised to 3 by 2. So 2 2s are 4. So 4 by 3 into x raised to 3 by 2. Put lower upper limit and lower limit, take their subtraction. You will get 28 upon 3 square units. So this area is nothing but 28 upon 3 square units. The next example is y is equal to sine x from minus pi by 2 to plus pi by 2. We know that sine 0 is 0. Sine 90 is 1. Sine minus pi by 2 is minus 1. So We have to find integration from this part to this part. Now you can clearly see that this area lies below the x-axis, and it is lies above the x-axis. So this area is negative and this area is positive. So we cannot integrate directly from minus pi by 2 to plus pi by 2. So we will make two parts of this area. This is the a1 and this is a2. So minus pi by 2 to 0, use y dx, and then 0 to pi by 2 y dx. So minus pi by 2 to 0 sine x, and 0 to pi by 2 sine x. Sine x is integral is minus cos x, then lower limit and upper limit. Use that formula and simplify. You will get the area to be 2 square units. Now this is the third example. Find the area of the region bounded by the parabola y square is equal to 16x and the line x is equal to 4. Okay, so y square is equal to 16x is the standard parabola open towards positive direction of x-axis, and this is the line x is equal to 4. So bounded by the parabola and the line. So this area we want to find out. Now clearly we know that the parabola is symmetric about x-axis. This parabola is symmetric about x-axis. So whatever area lies above the x-axis, the same area lies below the x-axis. So we can think of the symmetry of the parabola to find the area of this shaded part. So the required area is nothing but 2 times the required area is nothing but 2 times area of the region lies in the first quadrant only. So 2 times area POCP. So 2 times 0 to 4 y dx. But what is y? Y is 4 root x. So 8 into 2 by 3, x raised to 3 by 2, 0 to 4. So put lower limit and upper limit. You will get 128 upon 3. So the required area is 128 upon 3 square unit. Now find the area of the region bounded by the curves x square is equal to 16y, y is equal to 1 and y is equal to 4 and the y-axis. Now x square is equal to 16y is the parabola open towards positive direction of y-axis. X square is equal to 16y. The lines are given y is equal to 1 and y is equal to 4. Also it is given that the area lies in the first quadrant, so we have to find this area. If it is not given area lies in the first quadrant, then we have to find this area also. So y is equal to 1 to y is equal to 4. So here, as the area is bounded by y-axis, we have to use our second formula, integration y is equal to c to y is equal to d x dy. Then what is x for the given curve? It is root 16y. It is 4 root y, and its integral is from 1 to 4. So after putting the values, you will get 56 upon 3 square units is the area of this shaded part. Now find the area of the ellipse. And you can find area of any curve by using definite integration. So we are finding the area of the ellipse. X square upon a square plus y square upon b square is equal to 1. This is the ellipse. If you put x is equal to 0, you will get the vertex lies on the y-axis. If you put y is equal to 0, we will get a vertex lies on the x-axis. Here is b a0. This point will be minus a0. This is 0b. This is 0 minus b. Now to find this area, it is clearly we can say that this ellipse is symmetric about both the axes, either x-axis and y-axis, because the part which lies above the x-axis, the same part lies below the x-axis. The part which lies to the left of y-axis, same part lies in the right side also. So it is symmetric about both the axes. Now, so to find the total area, we will find the area lies in the first quadrant only, and then we will multiply it by 4 so that we will obtain the total area. Now simplify the given curve and obtain y, because we will require to put the value of y in our formula. So 4 times 0 to a y dx. So root a square minus x square, its integral is x by 2 root a square minus x square plus a square upon 2 sin inverse of x by a 0 to a. Now after putting the values you will get 4b upon a square by 2 pi by 2 minus 0 is equal to pi ab. So the area of the ellipse is pi ab square units. Similarly, you can find area of the circle x square plus y square is equal to a square by using the same formula pi ab. So area of the ellipse is pi ab square units. uh, Now in board what we will ask, find the area of the ellipse or show that the area of the ellipse is pi ab, and also find and hence find the area of the ellipse x square upon 16 plus y square upon 9 is equal to 1 for 4 marks. So in that case we have to use this formula to find the area of that particular ellipse. Now find the area of the region lying between the parabolas y square is equal to 4ax and x square is equal to 4ay. So these are the given two parabolas. First of all, we must able to draw their graphs. So this is the graph of the given parabolas. Okay. So this is the area lies between the two parabolas. So put uh, after simplify this, solving these two equations simultaneously, we will obtain the point of intersection. Okay, so x is equal to 0 and x is equal to 4a. If you put x is equal to 0 in these two equations, you will get y is equal to 0, and if you put x is equal to 4a, again you will get y is equal to 4a. So the 2 points where the curves intersect each other is 0 0 and 4a 4a. So the required area is lies in the first quadrant. So the area under the parabola, this parabola, first parabola, minus area below this second parabola. So 0 to 4a root 4ax dx minus 0 to 4a x square upon 4a dx. Take their integrations and put lower limit and upper limit. So after simplifying, you will get 16 upon 3a square is the area of the shaded part or area between these two curves. Now the next one is find the area of the region bounded by the curves y is equal to x square and the line y is equal to 4. So this is y is equal to x square parabola and the curve y is equal to 4. So this is the area we want to find out. Now the limits are given, that y's limits are given and the area is bounded by x-axis. So we will use the second formula. Also this area is symmetric about y-axis. So we can use that property, symmetric property. 2 times area of the ellipse lies in the first quadrant between 0 to 4. 2 times 0 to 4 x dy. What is x? X is root y. So find its integral. You get the required area to be 32 upon 3 square units. Now the eighth example is find the area of the sector bounded by the circle x square plus y square is equal to 16 and the line y is equal to x in the first quadrant. First of all, you have to draw the proper figure. Now as it is x square plus y square is equal to 16, so it is a standard circle. The center is at origin and radius is 4. So let's draw that circle. Then this is the line y is equal to x. Now y is equal to x is line bisects the coordinate axis. Bisects the coordinate axis. So the area bounded by x-axis and these two curves. So this is the required area. Okay. So we have to go from this 0 to 4. But we cannot go in one stroke only, 0 to 4 by dx. We have to find the area in of this triangle OBC and then the part ABC. Okay. So if you start from this 0 to 4 by taking this y, you will reach somewhere here up to 4. So you will acquired this much area more, but this is not the case. This y is only up to this. After that, this circle part is starting. So we have to integrate, we have to take two parts of this area. One is from 0 to this line and then from this line to 4. So we must able to find these the coordinates of these two, this point. This point is a point of intersection of these two curves, so we have to solve these two curves simultaneously. So after solving these two curves, we will get x is equal to plus minus 2 root 2 implies y is equal to plus minus 2 root 2. So this is the first point, 2 root 2 2 root 2, and the second point is this minus 2 root 2 minus 2 root 2. So what we will do, we will integrate this to find this actual area. We will take this y of this line from 0 to 2 root 2, and then from 2 root 2 to 4 we will take y from this circle. Okay, x square plus y square is equal to 16, so y is equal to square root of 16 minus x square. So use this formula. Root a square minus x square is x square x upon 2 root a square minus x square plus a square by 2 sin inverse of x by a, lower limit and upper limit. Simplify it and you will get 2 pi square units. This is the area of this shaded part. Now if you can think of this what actually this part is, it's the eighth part of this circle. Okay, this is first, second, third, fourth, fifth, sixth, seventh and eighth. This is the eighth part. Now we know that the area of the circle is pi times r square. So r square is 16, so here we get 16 pi is the area of the total circle. Now it is the eighth part, so we have to divide it by 8. So 8 2s are 16, so we will get 2 pi. Here also we get the 2 pi, so whatever the answer we got, that is correct. This is the uh, eighth part of the area of the circle. Okay, we will stop here. In next lecture we will continue the exercise. We will solve some of the exercise problems.